Hello everyone, how are you? This is part one of solving paper one multiple choice core number 12 February March 2024. Okay, in this part we are going to solve 10 questions and then we'll complete in the other parts. So question one says the diagram shows a pendulum that oscillates between P and Q. Which method is used to find the average period of oscillation for the pendulum? Let's remember, period is the time needed for one oscillation. Okay, so period equals to the total time over the number of oscillations. I hope you know this formula. This is a general formula. Of course, it will not be given in the exam. You should know it by yourself. So which option is correct here? Let's see option A. It says measure the time it takes to swing from P to Q. Actually, that's not correct because the one oscillation will be from P to Q and then back to P. Okay? Or in the opposite direction, maybe from Q until P and then back again to Q. Okay? This is the time for one oscillation, okay, or the one oscillation. In option B, they say measure the time it takes to swing from P to Q and then P again 10 times and then divide that by the 10. Exactly. So we find the total time for 10 oscillations and then divide it by the number, which actually uses this formula. So option B is correct. Let's see option C. They say after we take the time for the 10 oscillations, we multiply it by 10. No, actually we don't multiply, we divide. So option C is wrong. D, they say the time it takes from Q to P. It's wrong as we explained. So option B is correct. Question 2, a car moves through a measured distance S, the distance is S, in a known time T. Okay, what is the correct equation? We know from before that speed, they want here to calculate the speed. We know the speed equals to distance over time, right? Since distance here is given as S and time as T, so it is S over T. It's option A. For some students, unfortunately, they use S for speed. Actually, no, speed and velocity are V, okay? Speed is scalar, velocity is vector. So this is question 2. Let's go now to question 3. It says, on Mars, the acceleration of free fall is 3.7 meter per second squared, which is the gravity constant on Mars. They say, what is the weight of 2.0 kilogram mass on Mars? We all know that weight equals to mass multiple gravity constant or acceleration of free fall, which is going to be 2 multiple 3.7. If you use your calculator, you will get answer C, 7.4. Okay, and of course the unit is Newton because weight is the force of gravity, right? Good. Question 4 says, a rocket is traveling vertically upwards, okay? 3 vertical forces acts on it. The thrust acts upwards and it equals to 100,000 Newton. The weight acts downwards and equal to 80,000 Newton. Now, they say, what is the air resistance force acting on the rocket when it is traveling upwards at a constant speed? This is very important. When they say at a constant speed, when the speed is constant, this means that acceleration equals to 0 meter per second squared, which means that total force or the net force equals to 0, right? What is the net force? Net force is the sum of the 3 forces. Remember, since the thrust is going up, so we write thrust force minus weight, because it goes in the opposite direction, minus air resistance, I will name it R, equals to 0. Why R is minus? Because the air resistance goes against the motion. The rocket is going up, so air resistance is going down. Okay, what do they want? They want air resistance. Okay, so I take this to the other side, is going to be F thrust minus weight gives me the air resistance. So it is 100,000 minus 80,000 will give me 20,000, and it is going downwards, right? As we agreed, the resistance downwards, so it is A. Okay, I hope it's clear. Of course, the unit is Newton, right? Okay, question 5. An irregular plane object is suspended freely from point O. This is the point O. The object is displaced and then released. Okay, we move it a little bit, like in this direction or in the opposite direction. It swings a few times and then comes to rest as shown. So this is the object when it is at rest. What is the center, or where is the center of gravity? So when the object is at rest, it's not moving. Always remember that the center of gravity will be under the point of suspension. Okay, so the center of gravity must be down here. It must be below here at this point. Okay, I'll name it C. Okay, so it is vertically below O. Okay, below the point of suspension. I hope it's clear. In question 6, they say 3 situations are listed. Someone blowing air into a party balloon, okay. A crane lifting a block of concrete, a crane or a lift, okay. Lifting a block of concrete. 3, a pile of books at rest on a shelf. In which situations is work being done? Work. Remember, work equals to force multiple distance. Okay, so in order to have work, we must have a force and a distance. So let's revise the situations. Someone blowing air into a party balloon. Actually, there is a force of blowing the air, and there is a distance because the particles are moving from our lungs through our mouth to the balloon. So there is a force and a distance, which means we have work. In situation 2, a crane is lifting a block of concrete. Okay, so we are applying a force to move it a height or a distance. So we have a force and we have a distance, so we have work. Situation 3, a pile of books at rest on a shelf. So there's no distance, which means no work. So actually we have work in situation 1 and 2. This is option B. Okay, I hope it's clear. Question 7. Which row describes an advantage and disadvantage of wind turbines? Okay, let's read the advantages. No fuel needed. Yeah, this is advantage. Variable supply. No, this is not advantage, because when the supply varies, it means it's not constant. This is not good. In C, they say no harmful gases released. Exactly, this is an advantage. D, constant supply. Actually, it doesn't give me a constant supply, because if there's no wind, there's no energy, right? So that's not an advantage. Disadvantages, harmful gases released. No, actually, there's nothing like that. Fuel needed, it doesn't need a fuel. Disadvantage, variable supply. Yes, this is disadvantage. This is disadvantage. Noisy, yeah, it can be noisy. So which option is correct for advantage and disadvantage? Is actually option C. Okay, I hope it's clear. Let me adjust the frame, sorry. Okay, please feel free to ask any question below the video. Okay, Now, the diagram shows a rectangular metal block with dimensions 2.5, 3.0, and 4.5 centimeters. The block is resting on the ground. Okay, the block exerts a pressure. I have pressure 0.23 Newton over centimeter squared. Okay, what is the weight of the metal block? Let's remember. So pressure equals to force over area. So here it is force of weight over area. Okay, what do they want? They want the weight. I have the pressure and I can find the area. So I adjust this formula. So weight equals to pressure multiple area. Okay, so which area is that? The area is the side of the block that it is resting on. So it is this area down here. Okay, so this is the area which has dimensions 2.5 and 4.5. Okay, so it is a rectangular surface. So we know pressure is now 0.23 multiple area is 2.5 multiple 4.5. Okay, this is 5 and this is 2. So if you use your calculators, you will get the answer. I did it already before. It is, yeah, it is option C, 2.6 Newton. Okay, 2.6 Newton. Somebody might ask me, Mister, don't we have to change the centimeter to meter? Actually, no, because pay attention here in the pressure, they gave me Newton over squared centimeter. So no need to change. I hope it's clear. Let's go to question 9. In question 9, they say which row correctly describes the movement of particles in solids and liquids. We know in solids it vibrates, right? So in option A, they say no movement for solids. No, this is wrong. B, no movement. This is wrong. In C, they say vibration only, vibration only. Both of them are correct. Let's see for the liquids. In C, they say move around each other. Yeah, this is correct. In D, they say vibrate. No, actually, they don't vibrate. They move around. Maybe they vibrate a little bit, but mainly they move around. So it is option C. Okay. Now question 10. This is the last question for this video. What is the boiling temperature of water at standard atmospheric pressure? We know the boiling point for water is actually 100 degrees Celsius, right? So I see the options are in Kelvin. We already know that temperature in Kelvin is actually equal to the temperature in Celsius degree plus 273. So we add 100 plus 273, it will give me 373, and the option is D. Okay, I hope it's clear. For the other videos, we're going to make other parts. Okay, please feel free to ask any question you want, and I'll see you in the next video. Have a nice day. Bye bye.